Hello everyone, our topic is differentiability. So here differentiability means again fx, our function fx is differentiable at a point, taking example a or not. To check that whether our function fx is differentiable at x means to say our left hand derivative is equals to our right hand derivative at x equals to a. That is the concept of differentiability. In short, you can remember it as differentiability means unique tangent to a function at a point. Unique tangent to a function at a point is called differentiability, and the rule is as simple as or as similar as to our continuity. So here, as said, left hand limit and right hand limit, so writing it with respect to a with respect to a, left hand a minus our function, we are doing derivative, so differentiation divided by x minus a. Left hand derivative is equals to my right hand derivative, that is limit x tends to a plus fx minus fa divided by x minus a. So here see the concept, fx minus fa divided by x minus a, fx minus fa divided by x minus a, but the interval left hand and right hand. Okay, suppose the function is not split. So when the function is not split, we will use H method. H method is saying for the left hand derivative, let x equals to a minus h. So limit x h tends to 0. Right now we change our x to a minus h. So h tends to 0, f a minus h minus of f a divide by a minus h minus a. That means limit h tends to 0, f a minus h minus f a divided by minus of h. Similarly, for the right hand limit, let x equals to a plus h. Please remember our journey. The journey has done minus and the journey has to be covered plus. So limit h tends to 0, my mistake, f a plus h minus f a divided by a plus h minus a, that is plus a. So this is called H method when the function is not split. And if it is split, use your direct method. Doing it and understanding it with one example. So here is the example that whether the following function fx is differentiable at x equals to 1 and x equals to 2 or not. The function is given x if x is less than 1, 2 minus x if x has the condition greater than equals to 1 and less than equals to 2, and minus 2 plus 3x minus x square if x is greater than 2. So let's check it. So here for x equals to 1 means to say at x equals to 1 means to say my left hand derivative and my right hand derivative. Then at x equals to 2, again left hand derivative and right hand derivative. Checking for first x equals to 1, limit x tends to 1 minus fx minus f1 divided by x minus 1. Okay, f1. So limit x minus 1, x 1 minus, so it is my 2 minus x. my mistake, I have not seen it. X, so it is my limit x tends to 1, x minus 1 divided by x minus 1, which is 1. Now checking for right hand derivative, so limit x tends to 1 plus fx minus f1 divided by x minus 1. So my right hand derivative greater than 1, so this is the condition. Here it is. So limit x tends to 1, I got 2 minus x minus 1 divided by x minus 1, which is minus of 1. So here I got my left hand limit is not equals to my right hand limit, means function is not differentiable. Same thing or same concept I will follow for x equals to 2, showing you with h method. So left hand derivative x is a minus h, so limit h tends to 0, f a minus h minus f2 divided by minus h. Putting the values, limit x tends to 0, so h tends to 0, f2 minus h minus f2 divided by minus of h, that is okay, it is 2 minus in bracket 2 minus h minus 0 divided by h, so I guess it will be minus 1. Next, my right hand derivative, so limit h tends to 0, f a plus h minus of f a divided by h, so limit h tends to 0, f2 plus h minus f2 divided by h, so limit h tends to 0. So here we have minus 2 plus 3, 2 plus h minus 2 plus h whole square minus of 0 divided by h. On solving it, you will get 1. So again I found my right hand side and left hand side derivatives are not equal. So hence I got that these functions are not differentiable at x equals to 1 and at x equals to 2. So this is the end of the concept of differentiability. All the best, guys.